grain is the lifeblood of the modern brewery, and this facility is designed for maximum efficiency.
The automated sampling probe at the W02 Tech Brewery intake station ensures every load of wheat meets a...
Utilizing near-infrared spectroscopy, the machine accurately determines the protein, moisture, and gluten composition of the grain.
The infrared sensor meticulously scans the silo's contents, providing a precise topographical map of the grain. The semi-permeable membrane utilizes a cellular structure that permits the passage of pure H2O molecules. The malting process begins with the push of a button, activating the grain sequence.
Here at WZO2, the grist is rapidly transported by air directly to the vats, ensuring maximum efficiency.
Through microscopic time-lapse, we observe the gelatinization process as the starch absorbs the fluid.
The mash temperature is critical, rising steadily until it reaches exactly 62 degrees Celsius for the saccharification rest.
This enzymatic activity is crucial for breaking down complex carbohydrates into usable sugars.
The mash tun reaches 72 degrees Celsius, the optimal temperature for the saccharification rest.
The mash mixture undergoes liquefaction, converting starches into soluble sugars.
As the mash settles, the agitator slows to a gentle stir, preventing compaction of the grain bed and preparing for the next phase. This specialized 316L steel piping ensures the integrity of the mash as it is transferred to the next stage of the brewing process. The lauter tun utilizes a natural bed of grain husks to clarify the wort through slow, steady filtration.
The backlight highlights the rich amber color and the turbulent flow of the wort as it passes through the sight glass.
Here we begin the sparging process, gently rinsing the grain bed with hot water to extract the remaining sugars in the lauter tun.
The refractometer provides a precise measurement. The sharp blue line settles exactly at 10.2 brix, indicating the sugar concentration.
These compressed hop flours are essential green organic matter. Notice the rough, fibrous surface of the pellets.
The condenser hood efficiently captures the churning steam, turning it back into condensation, a key part of the energy recovery process.
The tangential entry creates a vortex, effectively separating the trub from the clear wort through centrifugal force.
The separation detail is clear. As the whirlpool slows, the green-brown sludge, or trub,
The fluid dynamics are critical here. The clear wort is separated from the sediment cone with minimal turbulence.
This is the heart of the operation, the plate heat exchanger. It uses these corrugated stainless steel plates for highly efficient thermal exchange.
Heat is efficiently transferred across the thin plates as the counterflowing liquids move through the exchanger.
Here we see the pure oxygen being injected directly into the cool wort stream. This process, known as aeration, is vital for fermentation.
The soul of beer.
These healthy yeast cells are actively budding, a key indicator of a successful fermentation process.
Here in the propagator, we see the vigorous growth of the yeast biomass, critical for successful fermentation. The yeast pitching valve opens automatically, precisely dosing the thick, creamy yeast slurry into the wort.
In the nutrient-rich wort, the yeast cells slowly begin to wake up. This is the lag phase, a period of adjustment before fermentation starts.
The yeast cells absorb the sugar molecules, initiating the fermentation process and releasing ethanol and carbon dioxide.
The pressure is now steadily rising, entering the optimal green zone for safe operation.
This schematic view demonstrates the cooling jacket mechanism. The blue glycol flows through the double-walled steel. This stainless steel sensor provides continuous feedback, essential for precise thermal management.
The tank enters crash cooling. The turbulence stops. The liquid becomes still.
The lagering phase is critical. In the stillness of the cold room, the beer undergoes a slow maturation, refining its character within these vessels.
The time-lapse reveals how the chaotic elements dissolve, resulting in a cleaner, more harmonious molecular structure.
The beer is getting clearer inside the tank, but still slightly hazy. a key characteristic of this wheat beer during conditioning.
Inside the centrifuge, spinning at 10,000 RPM, the high G-force violently separates the dense solids from the liquid stream.
The beer enters the plate and frame filter press, where sterile filtration removes impurities, resulting in a perfectly polished product.
The outlet pipe from the filter. The beer is now brilliant, golden, and crystal clear.
The clarity is exceptional, truly golden, and the aroma perfectly balanced. It's ready.
The TX5000 series robot smoothly transitions to its ready position, showcasing the precision engineering central to modern automation.
All systems go.
An endless sea of glass bottles moves rapidly along the conveyor, a mesmerizing display of industrial scale.
Inversion, the twist rinser. Bottles are grabbed and flipped upside down in a spiral motion. Orientation. This pressurized chemical fogging ensures that the interior of the bottle is completely sterile before filling. The high-speed pneumatic kicker identifies and eliminates the defective bottle, sending it directly to the cullet bin for recycling.
This is the rotary filler, a massive carousel spinning with hundreds of filling valves, the undisputed heart of the brewery line.
This macro shot captures the CO2 purge process. The gas flushes into the bottle, creating an inert atmosphere and visible condensation. The cold beer flows down the inner walls in a spiral, a smooth laminar flow designed specifically to prevent foaming.
A tiny squirt of hot water hits the beer surface, forcing the foam to rise and push out the air. This process is known as fobbing.
Here, the laser checks the metal cap for any tilt or misalignment, ensuring quality control at high speed.
The bottles now enter the tunnel pasteurizer, a critical step where heat stabilizes the product, ensuring a longer shelf life.
This thermal treatment process, known as pasteurization, stabilizes the beer by eliminating potential spoilage organisms.
Exiting the tunnel, the bottles are met with a powerful, focused blast of air, removing moisture instantly.
The bottle surface is now dry and clean, ready for label.
Made from durable, glossy, transparent film, the new Corona wheat branding is rapidly supplied to the production line.
To ensure traceability, the laser etches a permanent production date onto every bottleneck at high speed. A river of glass bottles moves relentlessly towards the packaging area, showcasing the scale of this massive operation.
Utilizing smooth mechanical sorting, the system divides the flow into 4 precise lanes for distribution.
The robotic palletizer precisely stacks the cartons in an interlocking pattern, maximizing stability for transit.
Day and night, these industrial titans meticulously load the vessels that carry the lifeblood of global commerce across the oceans.
Day and night, these steel giants push across the open ocean, delivering thousands of tons of cargo around the globe.
As the Blue Hour descends, the backbone of the urban distribution network pushes forward, ensuring the city keeps moving.